Hello all. In this video we will solve the numerical for non-preemptive priority CPU scheduling algorithm. So we want to calculate average waiting time using non-preemptive priority CPU scheduling algorithm. Okay. So here also we are going to make use of a priority queue. Okay. And the execution or the order of execution of processes will be shown with a Gantt chart. So we start at time 0, and at time 0 we notice that process A arrives at time 0 and process C also arrives at time 0. Right, so both processes arrive at the same time. Assume that they are entered into the queue in this order A and C. Right, so at time 0 we have to decide whether A will get CPU or C will get CPU. The algorithm is priority based. So we will look at the priority of A. Priority of A is 3 and priority of C is 5. Now larger number denote smaller priority. So naturally A will get CPU because priority for A happens to be higher. Number is smaller but priority is higher than of C. And since this is non-preemptive algorithm, once a process gets the CPU, it will use it until it wants. So it will use it until third time unit. Okay, by the third time unit, so now A is not in the queue. A was using the CPU, right? So now by time 3 no one else has arrived, right? So naturally at time 3 there will be a context switch and CPU will be given to process C. Okay, now C want to use it for 2 units of time, so it will use it up to time interval 5. But in between time interval 3 to time interval 5 or time unit 3 to time unit 5, a new process comes into the picture and that is B. So that would be entered into the queue. Okay, so at time unit 5 there is only one process in the picture, that is B, so naturally B will get CPU. Now B will keep on using CPU until it wants. Okay, and it want to use it for 6 time units, so it will use it until 11. And at time unit 6 D arrives, so it is entered into the queue. And at time unit 8 E arrives, so E is also entered into the queue. These processes will come and simply sit into the priority queue without disturbing existing running process. Okay, and now there are no more arrivals, so naturally out of D and E the higher priority is for D because D's priority is 2 compared to E's priority as 4. So naturally now D will run. D will use CPU for next 5 time units, so that is up to 16, right? And finally E gets CPU for 1 time unit, that is 17, because the time bus time for E is only 1. Okay, now let us calculate the wait time for A, B, C, D and E. Okay, so now the wait time for A, so A came at 0, got CPU at 0 and then finished, so its wait time is 0. Process B came at time interval 4, right, got CPU at time interval 5 and then finished, so 4 to 5 it was waiting, so wait time is 1. Process C came at 0, got CPU at 3 and then finished, so its wait time is 3. Process D came at 6, got CPU at 11, so 6 to 11 it was waiting, so that is 5 units of time. And finally process E, which came at time unit 8 and got CPU at time unit 16, so 8 to 16 it was waiting, so that is 8. So this happens to be 17, right, is the total wait time. If you want to calculate average wait time, you divide it by the number of processes. Number of processes are 5, so this would be 3.4, right? So the average waiting time for this question using non-preemptive priority is 3.4. Okay, I hope you have understood this. Thank you.